Hey, welcome to Dinsmore Racing and our little segment we're going to have here today on differentials and the different types we have in industry. These are instructional videos or videos that you would like just to look at for your own pleasure, and you're welcome to view them whenever you like. We're going to discuss the different types of differentials that are used in industry today. The industry could be in the racing industry, it could be in the automotive industry, it could be in the trucking industry, or in the agricultural and construction and mining industry. And basically these differentials are just larger in size the larger we go up in pieces of equipment or vehicles. So we're going to discuss the different types in here that we have, and I have 4 different styles in front of me, and then we're going to go through the open diff today and look at it a little closer and put it together and assemble it so we can see the components inside of it and what we have on there. So in front of me I have 4 different styles here that we are going to look at, and the first one over here is our spool, and the spools are used in racing purposes only usually. Some construction equipment or ag equipment did use a spool in them over the years, but not highway equipment or anything like that because of the tire wear and the problems we have. This is a Eaton True Track, which has become a more and more popular today. Used a lot in the heavier industry in that, and in the performance automotive side of it, it's very common in that now, and we'll look at it a little bit deeper. Here is our limited slip differential that's been used widely over the years in different types of vehicles, automotive and off-highway. Different styles of this, and we'll discuss those styles when we get there. And our open diff, which is very common in all automotive today, off-highway, agricultural, and construction and mining and trucking industry. So open diffs are very common in all those industries today. So we're going to look at the different ones. We're going to see what's special about them and what's unique and why they're designed that way. So welcome to this segment of it, and we're going to get started here shortly and discuss each one. So the first one we're going to look at here is our spool. This is a direct drive. It really does not give us any differential action on it. We're going to talk about what happens in a differential and the design of it and why it's designed a certain way. And on the spool, the reason that it is not commonly used is because everything is one piece. So our axles, drive flanges would go on here to drive our axles on each end of it, and this is turned by our ring gear, and as our ring gear turns it, then both axles are going to have the same load on them at all times. So when we're going around corners, one will be skidding and one will be skipping, and it puts a lot of load on the drivetrain, and it is only used when we're in soft, muddy conditions or conditions where we would require both wheels to be locked all the time. And so that's the reason that we don't use it in any of our automotive side or anything, is because it causes too much tire wear and too many other issues with it. In racing applications, that's where these are mostly used, and we put a larger tire and a smaller tire, put stagger in the car so it follows around the circle track and doesn't have the tire wear, the scrubbing, and always has constant torque on the wheels out there. Or if we get in mud conditions, if we're racing in mud, we can use both the same size tire and allow the vehicle to slide in the corners and control it that way. So spools are mostly used in performance applications over in the industry. What we have to understand about these spools, whether they're a spool, a limited slip, a true torque, or an open diff, is everyone is going to have a ring gear which will attach to it, and it doesn't matter which one we put them on, it's going to bolt through the holes that are on it and attach to it. The purpose of a rear end is to change our linear drive, so our drive shaft turning our pinion gear, connecting to our ring gear, and allow that ring gear to change a right angle drive. So we put a linear coming in and we change that to our axle drive. So we do a right angle drive with it. So this ring gear could fit on any one of these if its application was correct, and it would drive that. So on our spool, this ring gear would drive the spool and both wheels would turn at the same speed all the time. When we look at our limited slip differential that we have here, and we connected our ring gear on it, we turn the carrier. And in the carrier, we have a pin that goes through this hole. And that pin goes through the hole, and it locates our spider gears. So the spider gears are mounted inside, and as this turns, the spider gears turn with it. Attached to the spider gears, we have our side gears. So these side gears are going to sit in here with our spider gear, and our pin coming down through our spider gear will drive our side gears. The spider is allowed to rotate around the side gear to allow one wheel to turn at a different speed. We do this so when we turn around corners that we can have one wheel turning faster than the other one without allowing any slip on the asphalt or pavement and wear of tires. So the limited slip differential uses this style is a cone style to provide that torque biasing that we want, so the torque to be applied from our ring gear through our side gear to drive the axle. We have two ways of driving this diff. We drive it with our pin, or we drive it with our cone through our axle. So this gives us a little torque biasing. This gives us a little turn on the axle, so we're always putting torque to both wheels equally as we are driving, and gives us a limited slip. On this style, and I'll bring this in a little bit so we can see it. On this style we have our cone, and we can see that has a taper to it, and that fits inside of our diff housing, carrier, and that gives us friction between the housing and the side gear, so we get some limited slip in there. It allows that to move a little bit in there and to drive. As that cone is pushed into the taper, it puts some of the torque bias on the axle and allows it to turn. We get our tension on our side gears because of these springs, and these springs are going to be loading and pushing these two cones out into the carrier. And as a force into the carrier, we allow some of our drive to go through our cone, but a lot of our drive goes through our pin and through our spider gears, which will attach. So when we come to corners, we can turn independently and allow the cone to slip on the inside and the vehicle to turn around the corner properly and drive that. What happens is, as one wheel speeds up, the other wheel slows down, so it almost gives it a reverse effect. And we'll see that when we get into our open diff how that exactly happens. And as we get that reverse effect on there, then what will happen is it will help that cone slip. So it gives it limited drive. That's where we get the term limited slip from. And as we have one that speeds up and one that slows down, it is going to allow this cone to slip a little easier. It gets a little back torque on it, and it will slide in there, and we have lubrication between these little pads on here and the housing, which allows it to slip without wear. This one has a lot of wear on it, and these side gears have chunks out of them, out of the side gears here, and the spiders have chunks out of them. This differential has a lot of problems in it. It has blown up. It has had the wrong lubrication in it. It did not get proper lubrication, and it caused a lot of wear. The cones actually wore so far into the housing that they actually wore on the face of the cone, which should never touch anything in here. It should be riding only on the taper, so it's worn it out so bad. And what happened is our clearance got so wide between our side gears that they actually started skipping and taking chunks off of them. So it was a wear factor from improper lubrication or wrong lubrication in the rear end, and allowed a severe amount of wear in there to cause it. So this is a limited slip. It allows torque to go to both axles, and when that torque's going to both axles, we can drive down the road. If we're in mud and one wheel gets on ice and one wheel is on pavement, it will give us some torque to drive through that, so we don't get stuck or we don't end up with wheel spin, and it will help deliver that torque bias to both wheels a little bit. So on the limited slip, we're going to allow that torque bias to both wheels, and we're going to allow a little bit of drive to both wheels through both axles. Like I said, if one's on mud and one's on dry asphalt, the one that's trying to spin will allow some torque to go through the drive housing, through our limited slip clutch here, and allow it to drive the other wheel, and we'll get some torque to pull us through the mud and carry on. And so limited slip becomes very well used through the automotive industry, and it's mostly used in smaller end trucks and vehicles to allow a posi type drive to both wheels, so both wheels are getting a positive torque to them at all times, and reduce the chances for wheel spin should one not have that. So that is our posi traction diff. The next one we're going to look at is this Eaton True Track, or the European model of this, I believe, is what we call a Thorson drive. And what we have in here is we have worm gears that are linear, and we have our side gears in here that our axles go into, the same as we have on our posi track or a limited slip goes into. But where we get our torque to each wheel comes from trying to drive the worm gear, because it takes a lot of force to drive a worm gear in one direction. It doesn't want to slip, so it gives torque bias to both wheels equally at all times. And inside of here we have 4 pinions down in here, and those 4 pinions are linear in here. You can't see them because it's all together, except for these little holes here. We can see just a little bit of each gear in these holes, and that allows that there's a lot of torque bias going to each wheel at all times. So should this rear end be in the mud or snow, it's always trying to put equal torque to both wheels at all times. The beauty that happens is when we release one wheel and we come to a corner and we turn one forward and one backward, one speeds up and one slows down, it unloads that worm gear, and it actually turns very easily then. So we can get into a corner and we won't get tire scrub, because it's going to allow that worm gear to move very easily inside of there and not drag the wheels in corners. These are very well versed in the trucking industry and heavy equipment. They've been used a lot in bigger stuff out there. The performance market has really grabbed a hold of these over the past years and welcomed them. European auto manufacturers have used these for several years. They've worked well in the front wheel drive or 4-wheel drives, where we can steer very easily, because when we turn one wheel faster we take that torque bias away, and it allows the differential in speeds of the 2 wheels. So that's how we get the name the differential, is we allow each wheel to turn at a different speed. It's a difference in speed in there. And we're going to see that really clear when we go to the open diff, which we'll go to next. So the True Torque, the worm drive style, more and more in applications we're using it today, and it provides a very good torque bias to both axles, so that when the ring gear is spinning it, both axles will get the same load, the same amount of torque that comes out of each one to drive it straight. So should one wheel get on ice and one wheel's on asphalt, this will drive you straight off of it and maintain the constant torque to each wheel, and until you start turning a corner and one wheel starts turning faster than the other, then it will allow it to freewheel internally and allow it to do that change that we have in the corners. And we'll see how that functions a little bit on the open diff. So here we have our open diff, and we're going to go through the components and how this functions. Once again, we have our ring gear, which will drive our diff and turn our diff housing, or carrier housing inside of the diff. I call it carrier housing because it carries the spiders and the side gears and all the components in that in here. This is going to make a little more sense when we talk about the different speeds of wheels. So the pinion is mounted, and as we turn it, it turns and drives the carrier assembly. Inside of the carrier assembly, we have a pin that goes through here, right in there. Put my screwdriver for a pointer. We have this pin in here, and this pin's going to go through our carrier assembly, and it's going to hold our spider gears in there. In with the spider gear, we have our side carrier gears, so we're going to look at those and how they go together. But we can see our spider gears inside of here. And as I turn my other side gear, we can see those spiders rotating around the pin that goes through. It is the pin that is turning the spiders, and the spiders being connected to our side gears, which drives the wheels. We call it an open diff because everything in here is free to turn however it wants. If I put my other gear on top, I can rotate this around, and we can see that gear actually rotating. So as my carrier's moving, and this wheel on the bottom is held, we can see how the top wheel is turning forward. If I turn everything at once, I want you to watch the speed of this. See how fast it's turning? Watch what happens when I hold the bottom one. I'm going to hold this bottom one and I'm going to turn it again. And watch that top one. Let me go back and reverse just a little bit here so you can see that just a little better. I'm going to hold the bottom one. See how fast the top one's turning? Watch when I let the bottom one turn. See how it slows down? And I hold it again, see how it speeds up? That is our differential. It's a differential in speed that happens. So on this rear end, if I'm in a corner, I can pick up speed and go around the corner. My outside wheel will pick up speed, my inside wheel will slow down, and it gives us a difference in ratio from what the input is from the ring gear to what the output is to the wheel. It's a difference in ratio. It is a differential. In an open diff, everything is free to turn freely in there. This diff is a diff that I'm building. I've already done all my clearance checks and everything on it. So we're going to finish assembling this, and I'm going to show you how that works a little bit more. I've already put the bottom side gear in it, and it has a thrust washer on it. I have put my spider gears, the 2 spider gears. We can have 2 or 4, depends on the application. The more I put on there, the more torque load I have on the housing. So if I have 4, I'm driving through 4 gears instead of 2. This is a light diff, it only has 2 in it. As we get into some of our trucks and heavier diffs, we have 4, and some of our big truck diffs I have seen with spiders with 6 pinions in them. So that we have, each one of these pinions helps drive. And it's the amount of teeth in contact with the side carrier teeth that gives us our strength. So on this diff, I'm only contacting on 2 teeth, and the touch is a little bit another teeth, so probably 3 teeth is full contact what I have. If I put 2 more in, I'd have 6. So I have twice the torque capacity to be able to carry through that. Depends what the diff is being used for. On this one here we have 2 spiders, which are doing the driving through the pin, through our side gears. That's the only thing driving these side gears, is those 2 spiders and that pin through there. So when I go to put this together, I have on here a thrust washer, I've already set the predetermined clearances on these, and I do those predetermined clearances with it dry so that the grease doesn't take up any of my clearance on there when I'm trying to check what my backlash on gears and components is. And then I lubricate them, and I've got assembly lube and grease on the shafts and on the shims in my spiders as I'm assembling. This is the other half of my carrier assembly, and I have my side gear is going to go through there and rotate for the other wheel. When we assemble this, we will assemble this all together through this pin through here. I forgot to mention there's a little pin that holds it in place in there. So if we want to remove this, all we have to do is tap that pin out, pull the carrier pin out, and that allows our spiders to come out and allows us to remove the other gear in here very easily. When we assemble, we want to make sure that we lubricate in these very well, because if we don't, then we're going to have those bind up on first assembly and have problems and issues in the seizing up, everything up. One area we have to really check when we're rebuilding a differential is check this pin for wear, check these side gears for wear, check for wear into the housing on our cup washers that are in there, and make sure none of that is worn at all so that we don't have any wear. When I assemble this, the one thing that I want to make sure of, I always assemble it in the same position I took it off. So we want to make sure that we mark the two housings in some way, or orientate them in a way that we know, so that we can put them back in the same way. And on this one here, I know when I put the numbers at this matches my numbers up top, so I orientated it when I took it apart. Quite often we'll put a center punch mark on them. I don't like using paint marks because when we put them in washers or through our cleaning processes, we lose that. So a little center punch mark works very well if you're doing these and not sure of them. The other thing you want to make sure of is that when you are putting them together, we want to make sure that we align the holes on them, because if the holes aren't aligned, then we are going to run into problems where the bolts won't go through. So what I like to do is drop something down through there to align it. You can use a screwdriver as long as it fits the hole fairly well. You can use a punch as long as it fits the hole well. We can use dowels or pins or bolts to put down through there, whatever you choose. When in the industry, there would be certain bolts that are cut off that fit down through there. I can even drop a couple of the bolts that are going to bolt it to the ring gear down through there to hold it in position when I put this together. And when we go together, we shouldn't have a lot of tension on these in putting these together. We can almost squeeze it together by hand. You may have to tap it down just a little bit. And when you're going to put components together, you don't want to beat them together. I'm just using a little wee tiny hammer. Candy cracker we call it. And I'll bring that down. So that allows us to put the ring gear on eventually. So our ring gear is going to bolt to it. It is going to rotate the housing, which is going to turn my pin, which is going to turn my spider gears and rotate the diff. And as long as everything's turning the same speed, the wheels will turn at the same speed. When I come to a corner, I can speed one up and slow one down. I can actually rotate this around, holding this side, spinning this side, the difference in ratio. The difference in ratio that happens, and I showed you this a minute ago, was that if I turn that, I'm turning at 1 to 1. It's turning the same speed. So we've gone through our differential. We have finished putting it together. We have taken our components and made sure that all the end clearances were correct before we did our assembly of it. And now I have aligned the carrier components, the two halves of the carrier and the ring gear, and I have put bolts in it to pull it up snug. I also have the other bolts in here that at this point now I would take and put Loctite on these bolts and put these bolts in there at the proper manufacturer's torque, on the proper procedure, and take the 3 out that I used to pull this together and put Loctite on those and make sure that they are correct. I have put the side carriers, drive flanges on here so I can show you now as this is together, a little bit more how it operates. With our ring gear, it would be, like we discussed, it's being driven by our pinion, and it's going to move the vehicle, propel it forward or reverse, depends which way it's turning. The pin is doing the driving through the carrier housing. The spider gears are doing the drive through the side gears and out through our axle flanges. So if our torque is equal on both wheels and we're on asphalt, this will move straight up and down the road without any problem. If I come to a corner and one wheel decides it wants to slow down, it's going to go around the corner and the other wheel is going to pick up speed. So if I hold this and turn this one, see how it walks around my hand? I'm just holding this side and it's just walking around. And that's what happens when we come to the corner. The outside wheel will increase in speed, the inside wheel will slow down, and around the corner we will go. And that's what the differential does. It allows a differential in speed between the 2 sides. The advantage of an open diff is we don't scrub tires at all hard. The disadvantage is if one wheel gets on ice and one wheel's on pavement, that we're going to get spin out, we're going to get the wheel turning faster, we're going to have no traction on that wheel, and this wheel's going to be sitting there, we're going to be stuck. With our limited slips and our true torques, then we could put equal torque bias to the wheels and we could drive out of that because the other wheel is already going to be trying to get some traction on the dry ground. That's the reason that we use them. As long as they're not in snowy conditions and muddy conditions, these will work very well, and they are used in most of our automotive, a lot of our agricultural, a lot of our heavy equipment will use an open style diff on them just to take pressure off components, because if we're starting to scrub off, axles get fatigued and everything else gets fatigued down the line as we're putting force to them. So hopefully you've enjoyed this little segment of differentials and have learned something about them and the components that are in them and how they operate and what the spider gear is, what the side carrier gear is, what the differential carrier is that we have in here, and the ring gear and the pinion to control the speed at which we're going to turn. Okay, thank you very much.